This video is going to talk about variables. Today, we're going to learn to write equations the way mathematicians write them. So instead of drawing a square or a diamond for the unknown, mathematicians usually write letters. We call the letters variables because the meaning varies or changes. This is a numerical expression. Well, would help. There you go. Everything in this expression is numbers and what operations you're using with them. If we replace some of the numbers with variables, we have an algebraic expression because it uses some letters. Now, you might notice here that I have a multiplication sign, and we know that because it's right there, and the letter X that is standing in for the number 3. Mathematicians, especially as they get older, they don't use an X for a multiplication sign. Instead, they use a dot. And that dot shows multiplication, 3 times 4. Or they can even use nothing. If you see that there is no sign between a number and a math sign, or a number and a letter, that means that those things are going to be multiplied. Just imagine there's an itty bitty little dot hiding in there, because mathematicians don't always write the dot. And you can see here that we have an example of a numerical expression and an algebraic expression. When letters are used in an expression, oh look, this is what we're talking about. When letters are used in an expression, the multiplication sign is often omitted or left out to avoid confusion with the letter X. So 2 times the quantity of n plus 4 is the same thing as saying 2 times the quantity of n plus 4. It's saying 2 of these things, which is what happens when we multiply. So they want you to rewrite each of these expressions. You go ahead and try it, and then come back. Welcome back. So this would be 2n. 2n plus 3. Don't forget the parentheses. 2 times n plus 3. There we go. We wrote it without a multiplication sign. Now they want us to write these expressions. A boat travels at a speed of 10 kilometers per hour. What distance will it cover in 2 hours? Well, that expression, to solve that, we would take 10 and multiply it times 2. And you can see I've got the dot there. I'm making it a little bit bigger right now. It's difficult to do with this. You want to make sure it's dark enough that the teacher can actually see it on the page. What distance will it cover in 5 hours? 10 times 5. You can see that I'm not solving this. I haven't been asked to solve it. I've been asked to write the expression. I've been asked to convert the words into math. Now they're asking, what distance will it cover in h hours? Well, how am I supposed to figure that out? I know that when it was 2 hours, I put a 2 here. 5 hours, I multiplied by 5. So when it's h hours, I'm going to multiply by h, 10h, or 10 times h. But this is the cleanest version, and not just because that 0 looks better than the other one. A house has 12 windows. How many windows do 3 houses have? Go ahead, write the expressions out for this page. Pause the video and come back when you're ready. Welcome back. So one house has 12 windows. How many windows do 3 houses have? Assuming they all have the same windows, we would do 12 times 3. What about 7 houses? 12 times 7. What about n houses? Well, how many is n? Who cares? We're being asked about n houses, so later we can say, well, what if n was 10? What if n was 200? We're using n to stand in the place of a number. They don't tell us what n is, so we don't care right now. We're just going to put 12n to show we don't know what this number is. We might find out later. We might never find out. but that's what you would do once you figure out that number. So we see figure 1, figure 2, figure 3. Yes, it's a little bit blurry. There's nothing wrong with your eyes. They want us to write an equation. How do we go from the figure to the number of blocks? What's going on here? Well, I know that figure 1 has 5 blocks, figure 2 has 6 blocks, figure 3 has 7 blocks. So what I'm going to do is I notice that for every figure, it has 4 more blocks than the figure number. 1 plus 4, 2 plus 4, 3 plus 4. So my equation would be the figure number, which would be looking at, let's call it n for number. To figure out how many blocks I would have, I would put n plus 4 equals, well, I don't know how many blocks there are going to be because I don't know what n is. So I'm going to say b for blocks. Now, look at how b can very easily be mistaken for the number 6. So instead, we're going to use capital B. N plus 4 equals b. You might have said b minus 4 equals n, and that's okay. Whether you pick capital or lowercase letters, it's okay. Just make sure that you stick with that because there's a big difference between a capital and a lowercase letter, and they can often represent different numbers. So they want us to write a formula for the new table. A to B. How do we go from A to B? Well, we just did this one. It's the same numbers as over here. We're just going to change up the letters. A plus 4 equals B. Because if I take this number 1 and I put it in A, I'm going to get this number. If I take this number and put it in A, I'm going to get this number. And if I take this number and put it in for A, I'm going to get this answer. 1 plus 4 equals 5. 2 plus 4 equals 6. 3 plus 4 equals 7. Even if the name of the columns change, the rule still has the same form. It's still A plus 4 equals B, or n plus 4 equal, we used b there too, so that's super convenient. So when looking at this one, I thought it was the same table for a minute. What is the difference between the two numbers in the first row? So what's the difference between these numbers? Well, 3 minus 1 is 2. So the difference, or I'll just put diff right now because I can't write very neatly in this, is 2. What's the difference here? 6 minus 2 is 4. What's the difference here? 9 minus 3 is 6. So the difference between the numbers is not consistent here, which tells me that I'm not going to be adding or subtracting here. I'm probably going to be doing something else. Since the difference between the numbers is not the same, we won't be adding or subtracting. So let's try multiplying. What number can I multiply 1 by to get 3? Well, 1 times 3 is 3. What can I multiply 2 by to get 6? 2 times 3 is 6. What can I multiply 3 by to get 9? Hey, look, it's 3. So now the new formula that we're going to write is first column times 3 equals second column, or A times 3 equals B. Or if you really want to write it the way mathematicians do, 3A, because 3 and A together, there's no sign, and no sign means multiplication, equals B. So they want you to find the rule and then write an equation for the table. You go ahead and give this a shot first, and when you come back, we'll talk about it. Welcome back. So the equation, for this table, and note that now we're into equations. We were talking about expressions before. Did you notice that jump? An expression does not have an equal sign. An equation has an equal sign. Expressions do not. So let's go ahead and find the equation for this table. How do I use A to get to B? Well, I know that I can add 10 to get 11. I can add 10 here. 2 plus 10 is 12. 3 plus 10 is 13. So my formula, my equation, is going to be A plus 10 equals B. And I can pick any column here and put the letter A in for A, the letter B in for B, and it'll work out. Go ahead and try this one. Welcome back. So let's try adding. 1 plus 1 is 2. 2 plus 2 is 4. 3 plus 3 is 6. Well, that's not going to work. Adding won't work. Let's try something else. The number's getting bigger, so let's try multiplying. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. Hey, look, multiplying by 2 gets us the answer every time. So let's go ahead and take whatever's in column A, multiply by 2 to get letter B. Go ahead and try this one. See how you can do it. When you come back, we'll talk about it. Welcome back. So I'm looking here and I'm seeing that these numbers are going up by 1 and these numbers are not going up by 1. So my guess is that addition's not going to work. Let's try multiplication. I know that 1 times 4 is 4. Is 2 times 4 8? Yes. Is 3 times 4 12? Yes. So I'm going to take the letter A, multiply it by 4 to get the letter B. 4A, or 4 times A, equals B. So in the ratio table, first thing they want you to do is we've already done these. The first one is A plus 10 equals B, and then it was 2A equals B, and then 3A equals B. In the ratio table, every row is a multiple of the first row. Which ones of these are ratio tables? Go ahead and try to figure that out. If you said that 3 is a ratio table, you are correct. We are multiplying to move our way down. If you said 2 is a ratio table, you are correct. We can see that in both of these, if you take the top row and multiply it by 2, multiply everything there by 2, you get the next row. Take the top row, multiply by 3, you get the next row after that. Even if the row after that was 5, 10, 5, 15, it's okay to skip numbers, but we're still multiplying to get there. However, letter I is not a ratio table, because if I multiply 1 times 2, I get 2, but 11 times 2 is not 12. So letter I is not a ratio table. We're going to answer a word problem by drawing a model, then writing an equation with squares, which you don't need to do, and then rewriting it. So Ricardo made 12 sandwiches. So let's look at sandwich 1, sandwich 2, sandwich 3, sandwich 4, sandwich 5, sandwich 6, sandwich 7, 8, 9, 10, 11, 12, and we're going to pretend those are perfectly equal sandwiches. 4 of them are avocado, 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 avocado. The rest are cheese sandwiches. We want to know how many cheese sandwiches does Ricardo have. So we could draw the picture and then we could go through and try to figure out, oh, how many of these left are cheese? We could count. But we're not going to do that. We're going to go ahead and make an equation. So what we know is that Ricardo made 12 of these sandwiches. There are 12 total. And in those 12 total, we know that 4 of them are guaranteed to be avocado. The rest are cheese. So if we take these out, we just have the cheese ones. 4 plus C. Or you can say 12 minus the 4 would be how we would solve that. Does that make sense? I don't know why I just asked that question to a video. Let's move on. So we can replace n with a number to get a numerical expression. For example, if we replace n with 3, instead of n plus 4, we get 3 plus 4. 3 plus 4 is the same thing as 7. I could also say, well, what if n is 10? If n equals 10, then this becomes 10 plus 4, because we're taking the letter n out and putting in another number. What if n was 13? Well, then it would be 13 plus 4. In variables, the amount that the letter stands for can vary. Writing 7 is called evaluating the expression because we are saying the value of the expression. Look, evaluate, value. Aren't words cool? They want us to evaluate this expression by replacing n with 3. So instead of n plus 2, it's 3 plus 2, which is 5. Instead of n minus 1, it's 3. 3 minus 1, which is 2. You don't actually have to write the number over the variable. I just do that to show this is what you do. Please don't do that on paper. It makes it very difficult to read. You go ahead and try these. Remember, n equals 3. You try to solve these on your own, and when you come back, we'll talk about it. Welcome back. So instead of 5 minus n, we have 5 minus 3, which is 2. Instead of 7 plus n, we have 7 plus 3, which is 10. Now we have 5n with no sign. We need to replace n with 3. But if I do that, then the number is going to be 53. That's not right. So I need to put that sign in the middle of those. What sign is it? Well, no, we have no sign up top, and no sign means multiplication, which means we are going to put a dot in between 5 and 3 to show 5 times 3, or 15. We could also write it, instead of with the dot to show multiplication, we can also use parentheses or the brackets. So we would replace n with 3 in parentheses, because now that 5 is next to the parentheses, there's no sign there, and we can multiply 5 times 3 instead of thinking that 5n when n equals 3 is 53, which is just silly. So they want you to go ahead and solve these. Go ahead, give it a shot, and when you come back, we'll talk about it. Welcome back. So we have here 5 times 4. 5 times 4 is 20. 7 times 3 is 21. 6 times 2 is 12. 9 times 6 is 54. I'm not doing anything different. I'm just reading that as multiplication because that's what it is. After evaluating an expression, then we add to it or subtract from it. So, when we have 5 times 4 plus 3, it means multiply 5 and 4, then add 3. This actually brings up something very important, which is the word Pemdas. You might know it as please excuse my dear Aunt Sally. This is going to be something that we talk about later on, but just know that I just like the word Pemdas. It's 2 syllables, that's all I have to remember. Anyways, 5 times 4 is 20 plus 3 is 23. So they're going to say, oh, we should put the parentheses around it, but that looks weird. So we'll just write it without the parentheses and know that we follow PEMDAS, or know that we're going to multiply first because we have the 5 directly attached to the 4. And you want to do things that are directly attached before you move outwards. So go ahead and solve these. Multiply first, then add. Give it a shot on your own, and when you come back, we'll talk about it. Welcome back. 3 times 5 is 15. 15 plus 4 is 19. 2 times 3 is 6. 6 plus 7 is 13. 3 times 4 is 12. 12 minus 5 is 7. 2 times 4 is 8. 8 minus 7 is 1. Now they want you to replace n with 5 and then evaluate. They're telling you n is 5. Go ahead, give this a shot. When you come back, we'll talk about it. Welcome back again. So instead of 3 times n, we have 3 times 5, which is 15. Instead of 10 times n, we have 10 times 5, which is 15. Then we have 10 times 5 plus 1. 10 times 5, 10 times 5 is 50. That's what I get for moving so fast. I try to keep the video short, but then I end up making silly mistakes. Then we have 10 times 5, which is 50, plus 1, which is 51. 10 times 5 minus 2. 10 times 5 is 50, minus 2 is 48. 10 times 5 plus 4. 10 times 5 is 50, plus 4 is 54. 8 times 5 minus 7. 8 times 5 is 40. 40 minus 7 is 33. Using different variables in the same expression doesn't change the meaning of the variables. They're going to tell you, if over here we see 2n plus 3, 2p plus 3, 2t plus 3, 2w plus 3, we see n equals 5, p equals 5, t equals 5, w equals 5, we're going to get the same answer for each of these. If they tell us n equals 5, p equals 2, t equals 7, then we're going to get different answers for each of those equations. N will not always equal 5. N could equal 7,000. N could equal 2. It will change a lot. So don't ever assume n is always 5. Ladies and gentlemen, I hope that you have an absolutely fantastic day.